All right, let's get right into it. Take a look at this number, 5 digits. Seems pretty ordinary, right? But what if I told you that this number might be holding a secret? A secret so profound it could change how we think about the very fabric of mathematics. Today, we're going full-on forensic investigator, and our subject is a single integer. Here it is. This is our guy, 28,757. For the next few minutes, I want you to forget that this is just a number. Think of it as our lead suspect, maybe even a key that could unlock a hidden door between two completely different mathematical realities. And this quote just nails the central question of our investigation. Apophenia, if you haven't heard of it, is our very human habit of seeing patterns where there's just random noise. You know, like seeing a face in a cloud. So are we about to uncover some deep, elegant structure, or are we just tricking ourselves? That's the question we're going to dig into.
Okay, so first things first. Every investigation needs a little context. Our crime scene, if you want to call it that, is the world of number theory itself, a field where mathematicians are basically detectives, always hunting for order in what looks like an infinitely chaotic universe of numbers.
The easiest way to think about this is that numbers live in two separate worlds. On one side, you have the additive world. It's nice, it's simple, it's totally predictable. 1 + 1 is 2, + 1 is 3, and so on. It's just counting. But then, you have the multiplicative world. This place is ruled by prime numbers, and it is chaotic, wild, and deeply mysterious. And for centuries, finding a bridge between these two worlds has been one of the biggest holy grails in all of math. And that, of course, brings us right back to our suspect. What if 28,757 isn't just living in one of these worlds? What if it's actually something like a Rosetta Stone, a special key that lets us translate between the simple, orderly language of addition and the wild, chaotic language of primes? So how do we find out? Well, we do what any good investigator does. We got to look for clues inside the number itself. We're about to crack this thing open and see what it's really made of. And when we talk about a number's DNA, what we're really talking about are its prime factors. You see, breaking a number down into the unique prime numbers that multiply together to create it, that's like running a DNA test. It tells you exactly what its fundamental building blocks are. So let's run the test. When we factor 28,757, we get a hit. It's the product of two primes, 149 and 193. Now I know, looking at that, it doesn't seem like much. But trust me, this simple little equation is the first critical piece of evidence. The real secret isn't the numbers themselves, but where they are. And here's where it gets really interesting. The key isn't 149 or 193. The key is their location on the number line. It turns out they are clustered together in a way that is, well, it's just very suspicious. To see what I mean, let's bring in a key point of reference, the number 192. Now, in the particular framework we're using here, numbers like this one, which comes from the formula 3 × 2 to the power of 6, are called harmonic grid nodes. Just think of them as major landmarks or intersections on a giant map of all numbers. Their whole purpose is to show us how other numbers relate to them. And now, look at this. Our two prime factors, they're not random at all. They're huddled right up against our harmonic landmark. 193 is just one single step away, and 149, it's exactly 43 steps away. Now, for two related primes to be so tightly and symmetrically clustered around a major grid point, that's highly unusual. It's a huge clue. And that other number, 43, make sure you file that one away. It is going to become very important. Okay, so the clues are pointing somewhere interesting, for sure. But to go deeper down the rabbit hole, we're going to need a more specialized set of analytical tools. These aren't your normal calculator functions. Think of them more like special lenses designed to reveal hidden patterns. Our first tool is something called the 36 tool, and honestly, the easiest way to think about it is like a sorting hat for prime numbers. No, seriously, it takes any prime, does a specific kind of division with 36, and based on the result, it assigns the prime to one of 4 special groups. It's all about mapping their geometric relationships. So these are the 4 groups, or arms, that the sorting hat uses. The only thing you really need to know for our investigation is that according to this system, our prime factors and our main suspect, 28,757, each get assigned a very specific, non-random address within this whole structure. Our second special tool is the recursive list. This one is kind of like Sonar. We systematically ping our number against those harmonic grid landmarks we talked about. those points from the 3 times 2 to the power of n formula. By doing this over and over, we're basically listening for our number's unique echo, its hidden resonant frequency. All right, we have our suspect, we have our evidence, we have our strange tools. Now it's time to put it all together. Let's apply this recursive analysis to 28,757 and see what it spits out. Because this, right here, is where the whole case breaks wide open. So, let's run the first test. We take our number, 28,757, we find the closest major grid landmark just below it, which happens to be 24,576. Then we subtract to find that distance, that first echo. So what's the result? The result is 4,181. And I know what you're thinking. Okay, another number. So what? Well, this isn't just another number. This is the smoking gun. 4,181 is the 19th number in the Fibonacci sequence. You know, the famous sequence that shows up everywhere in nature, from seashells to spiral galaxies? The odds of a number's first echo just randomly being a Fibonacci number are less than 0.1%. This is a massive breakthrough. In this system, they call this a no-stella, a 0 point, where all the chaos suddenly snaps into a perfectly meaningful pattern. But that's not even all of it. As the investigators looked even closer, kind of zooming in on the smaller harmonic grid points, another pattern started to emerge from the static. It wasn't just a one-time echo. It was a repeating signal, a constant resonant frequency. And this just shows it brilliantly. Hey, remember that number 43? The distance between our prime factor 149 and that grid node 192, the one I told you to remember? Well, look, it shows up again and again and again. The system keeps stabilizing at plus 43 and its mirror, negative 43. This is not random noise. This is the number's heartbeat. So, let's bring all this evidence together and deliver the final verdict. What is the true identity of 28,757? After all this, what have we really discovered? We basically have 4 key pieces of evidence. First, you've got the Fibonacci number, which acts as this incredible bridge between the two worlds. Second, you have the harmonic offset of plus 43, which is like its core frequency. Third, you have its mirror image, negative 43, showing the frequency is stable and symmetrical. And finally, that simple little offset of 1 from its other prime factor. Altogether, these 4 stabilization points, they tell us that 28,757 isn't just a number, it's a machine. It's a resonance filter that takes in chaotic, multiplicative information and outputs beautiful, orderly, additive patterns. Which leaves us with one final, pretty mind-bending thought. We started by asking if this was a real discovery or just us seeing faces in the clouds. The evidence seems to be pointing to discovery. It suggests that what we usually dismiss as pure coincidence might actually be a hidden map, a deep structure connecting the foundations of our mathematical universe. And it really makes you wonder, right? How many other numbers are out there, hiding these profound secrets in plain sight, just waiting for someone to look at them in the right way?